Okay, pre-calc. So welcome to our new unit. This is going to be trigonometric identities. So you'll be able to access these notes via Google Classroom. They should have uploaded just about 5 minutes before I uploaded this video. And the notes for you guys are called the student packet. So you can follow along or you can print it out. But if you can't print it out, you're going to have to switch it up and just do notes in your notebook, unlike what we've done in the past, just because I can't get you the packets myself, unfortunately. So you might be a little intimidated here because the first page is a little crazy. I would highly suggest printing this guy out as a reference sheet because we're going to be using it throughout this entire unit. Our first lesson today, we're just going to kind of take a look at some trigonometric identities, what they actually are, and then how we can use them. So to start off, we're going to go ahead and define what a trigonometric identity is. So essentially all trigonometric identity is an equation that's always going to be true for trigonometric functions. Right? What we can do with these, we can either evaluate a function, so we could figure out other trig values. We can simplify expressions down. We can verify identities, which means we can prove something. And then we can also solve equations. So we're going to start off with our basic identities. And they are written again for us right here. But remember, I highly suggest printing out that trig identity little cheat sheet that's on the front page of the student packet. Right, so the basic identities we're going to look at right now are the quotient identities and the reciprocal identities, which we've dealt a little bit with in the past. Okay, first, the quotient identity just says that tangent of theta is always going to be equal to sine over cosine, and that's as long as cosine is not 0, because as you can see, cosine's in the denominator. That's not going to work for us. Okay? The other quotient identity is that cotangent is the flipped version of that, cosine over sine. Our reciprocal identities are just claiming that our reciprocals are the flipped version of each other. For example, sine is equal to 1 over cosecant, cosine 1 over secant, tangent 1 over cotangent, and then we can flip all those guys. We can say that cosecant is actually the 1 over sine of theta, and then secant is 1 over cosine, cotangent is 1 over tangent. Okay? So what we're going to first do is we're just going to use these trigonometric identities in order to find missing function values that we're looking for. So if you take a look at number 1, we have if secant of theta is equal to negative square root of 30 over 3, find cosine of theta. So the first thing we're going to do here is we're going to decide which one of our identities to use. So we're going to look for an identity that has cosine and secant in it, and I would prefer to have cosine isolated because that's what we're looking for. So the first one I notice is my reciprocal identity right here. All right, so cosine is equal to 1 over secant. So that's what I'm going to use. And what I can do there is I can just plug in the things I know. What I know is that secant is equal to negative square root of 30 over 3. So I just plugged in negative square root of 30 over 3 for secant. After that, I can simplify it down, and that should give me cosine, right? At the beginning, we said cosine is equal to 1 over secant. What we have to do here is, because we have a fraction inside of a fraction, we have to do a keep, change, flip. So I'm going to keep the 1, my numerator. I'm going to change division to multiplication, and I'm going to flip this guy. So it's going to be 3 over root 30. Negative, right? And that just gives me negative 3 over root 30, which I have to rationalize. Remember that's because we can't have a radical in our denominator, so I'm going to multiply the top and bottom by that radical. Looks like I get negative 3 square root of 30 over 30, and then to finish off, I'm going to simplify down. So 3 over 30 is 1 over 10. So it looks like cosine ends up being negative square root of 30 over 10 by using our reciprocal identity there. Okay, for number 2, we're going to use the quotient identity. So check out number 2. We say if tangent of x is equal to square root of 2 over 4 and cosine of x is equal to negative 2 square root of 2 over 3, find sine of x. So in this case, the identity that works best for us that has tangent, cosine, and sine involved is this quotient identity right here, right? Tangent is equal to sine over cosine. So I'm going to go ahead and I'm going to write that guy out. And I'm going to plug in everything I know. So I know a few things. I know that tangent is actually the square root of 2 over 4. I do not know what sine is. I'm trying to figure out what that is, right? And I know that cosine is negative 2 square root of 2 over 3. Okay, so I want to get sine by itself and figure out what it's equal to. So I got to get rid of this denominator. I'm going to multiply both sides by that in order to isolate sine. Right, so let's show our work over here. I'm going to do negative 2 square root of 2 times square root of 2. That's negative 2 square root of 4 over my denominator is 3 times 4. That's just 12. Right? So we have sine all by itself. All we have to do now is just simplify that down and we'll have what sine is equal to. So the square root of 4 is actually 2. I'm just going to show how this guy, so that's going to be negative 4 over 12, which is going to be negative 1 over 3. And that gives us our answer. So we were given tangent and cosine, and we were able to find sine using our quotient identity. Right? So for number 3, you'll notice a few things. One is that we have this weird new variable. I think this is beta, but don't quote me on that. Just all I need you to understand is that anytime we see these variables, they're the same thing as x or theta, any of that good stuff. You'll see a couple other ones that are a little goofy looking as well. All right, so for this one, we know cosecant is 7 over 3. We also know cotangent is negative 2 square root of 10 over 3. And we also want to find secant. Okay, so this one's kind of interesting because we have cotangent and then we have cosecant and secant here. Okay, so if I'm looking at all my identities here, it looks like my reciprocal identities don't have enough of these guys intertwined. So when I look at my quotient identity, I have a little bit more going on. I'm actually going to use this guy. Okay, the reason being is because I know I already have cotangent and I can actually find sine real easily. Remember, cosecant is the reciprocal of sine. So sine is just going to be equal to 3 over 7 in this scenario. Right? So that actually means that I know cotangent and I know sine. All I have to do is plug in both those guys and I'll find cosine. You might be thinking, hey, we're not trying to find cosine, we're trying to find secant. But remember, cosine and secant are reciprocal, so it'll be really easy to find secant once we find cosine. So let's go ahead and finish this guy off. We said we're going to use this quotient identity, so we're going to do the cotangent is equal to the cosine over the sine. And the two things we know cotangent is negative 2 square root of 10 over 3. And we also know that sine is 3 over 7. Okay. So to get rid of this guy, we're going to have to multiply by 3 over 7 on both sides. And that'll eliminate that denominator on the right. And I'm going to move my work over here. I'm going to have 3 times negative 2 square root of 10 is negative 6 square root of 10. And 7 times 3 is 21. So I have cosine isolated. I do have to reduce it. Negative 6 over 21. 3 goes into both of them, right? So that's going to be something like that. But as I mentioned earlier, we weren't trying to find cosine. Right? But it does help us get to our final answer of secant. Because all we got to do is flip that guy. And we could say secant is going to be equal to negative 7 over 2 root 10. But we do have to make sure we rationalize that guy, which means we're going to go ahead and we're going to multiply the top and bottom by the radical, which is radical 10. So that's going to be negative 7 square root of 10 over, that bottom's going to end up being 20. And there we go, we have our answer. Okay, so all I want you guys to do is to go ahead and flip over, not the next page, but once you go to homework 1, I want you to do numbers 1, 2, 3, and 4. You should have all the tools to be able to do that. And once again, please make sure that you either print out this trigonometric identity reference sheet or you go ahead and have it available on your computer whenever you're doing any of this work. And hope you guys have a good day.